Today we're going to be working on lesson number 6. We're going to be looking at data and trying to identify the type of function that we have and then actually find the equation. So again, this is a repeat of everything that we have done, but now these equations could be a little bit more complex. So what I want you to do is look at page S49 right now, and I want you to take a look at my first data table. The first thing that you should be eyeballing is you should be looking to make sure that your change in x is consistent. And in this case, the x's are going up by 1. I then also want to look at the change in my y's. And when I take a look at my y values, I'm going to notice, woohoo, they are going up by 2's. Since I have a constant change in the y, I should then recognize that I have a linear function. Okay, a couple of ways now that we could find this equation. I could take two ordered pairs, 1, 5, and 2, 7, which I'm just getting from my table. And I could calculate my slope, which I would get as 2 over 1. And then I could substitute that into y is equal to mx plus b. And again, choose one of the ordered pairs for your x and your y, and find my b. So we should know how to do this manually. And I get b to equal 3. So my slope is 2, and my y-intercept is 3. And that should be the equation of my line. Y is equal to 2x plus 3. Now what I would like you to do is I would like you to take out your calculators and put that under y equals 2x plus 3. And then I would like you to hit second table to verify that you get the table that's shown in front of us. And that's how you're going to do it with the use of the calculator as a check. Now there's another nice way of doing this. And I'm going to show you, it's kind of a shortcut, but it's not really a shortcut. We're going to then take out our calculators, and I have two pieces of information here. I have my x values, which I'm going to call L1, and I have my y values that I'm going to call list number 2. So in our calculator, if I go under Stat, Edit, okay, if you have anything in the lists, clear them out. And under list number 1, let us type in my x values. So I have 1, 2, 3, 4, 5. And then under list 2, I'm going to type in 5, 7, 9, 11, and 13. Because I eyeballed the chart and I realized my first difference is the same, I now know I'm dealing with a linear function. So now I'm going to go under Stat, Calc. And over here, if you look at number 4, that's my linear function. So I hit Enter for 4, hit Enter one more time in my calculator, and it gives me the equation. Y is equal to ax plus b. They're telling me a is 2 and b is 3. So my equation is y is equal to 2x plus 3. And that is a nice way of doing it with the use of the calculator. Now let's go on to page number 50. And I want to look at my next table of values. So the very first thing I'm going to do is I'm going to look at my changes in my x's. And I realize that they are going up by 1's. And then I'm going to be looking at the changes in my y's. So when I go from 6 to 9, I'm increasing by 3. From 9 to 13.5, I'm a little bit different. It's 4.5. And then I'm going up by 6.75. And then I'm going up by 10.125. Okay, let's check out our second difference. Here I'm going up by 1.5. And here I should recognize I'm going up by 2.25. My second one is different. So right now I know it is not linear, and I also know it is not quadratic. My second difference is not the same. How do we check for exponential? When I have an exponential function, I know that my ratio has to be the same. I have to be able to figure out how am I going from the y values. So let's take a look and let's check for a common ratio. So write this down. Check for a common ratio. Okay, so when I am looking and I go from 6 to 9, I end up with the 9 and I started out with the 6. So take your calculators. 9 divided by 6 is going to give me 1.5. Which means that I took the 6 and I multiplied it by 1.5 to get the 9. When I take a look at the next two ordered pairs for the ratios, 13.5 divided by 9, and I do that in my calculator again, I am going to get 1.5. Ooh, I think I may have found something. When I go try the next one, and you have to try all of these, 20.25 divided by 13.5, sure enough, again, I get 1.5 as my ratio. And then try the last guy, 30.375 divided by 20.25. Again, I get 1.5. So I did find that I have a common ratio. Okay. Now, a couple of ways that we can do this. I'm just going to erase this now. I can use my formula where I have a sub n is equal to a sub 1 times r to the n minus 1. That is my geometric sequence formula. I am given a sub 1, my first value here is 6. My common ratio is 1.5 to the n minus 1. And that's how you would do it by hand. Okay, so your equation would be 6 times 1.5 to the n minus 1. Now let's try this guy in my calculator. So again, I'm going to take out the calculator, and I'm going to go under my stat, edit, and I'm going to clear out my list. Now, my x values are still 1 through 5, so I can leave L1 fine. That's okay the way it is. And now I'm going to type in 6, 9, 13.5, 20.25, and 30.375. So there are my two lists. I'm then going to go under Stat Calc, and I think it's exponential. So when you scroll down in your calculator, the exponential is that 10th one, or the 0, EXPREG, exponential regression. Hit enter. Hit enter one more time. And what they give me here is they give me y is equal to a times e to the x, a is equal to 4, and b is equal to 1.5. So when I put this into that equation, I'm going to get 4 times 1.5 to the x. Now, that is also correct, which is very different than the one that I had just written out. Why are these two different? The calculator starts with the 0th term. The equation I manually is the first term. So again, I'm not really sure if this is correct, but if I know my 0th term, so again, I'm going to put 0 over here, is 4. Let's see. Does 6 divided by 4 give me 1.5? And it does. So my 0th term in this case is 4. My first term is 6, which means these two equations are equal to each other. Either equation would be the correct answer. Let's use our calculator to check that, because again, I'm not sure and I want to make sure I get that table of values. Go under y equals, and let's type in our first one. 6, parentheses, 1.5 to the, now you have to put this guy in parentheses, x minus 1, because the minus 1 is the entire exponent. And let's now type in the other one. 4 parentheses 1.5 to the x. And if I do a second table, again, I'm checking my table of values. Notice my y1 and my y2 happen to be the same, so I know these two equations are equivalent. And when I compare them to my tables here, I do get the 6, the 9, the 13.5, the 20.25, and the 30.375. So these two formulas are exactly the same. Either one would be correct. If it's a multiple choice question, pay attention to whichever piece of information they give us. Okay, now we're going to go on to letter C. I'm just going to erase all of this and we're going to look at the next one. Letter C. So again, I give you another table of values. And the first thing that I'm going to check is I'm going to look at my differences. So my differences in my x is 1. And when I look at the differences in my y's, all of a sudden, it's not linear because my differences are different. So please write that out. Let's take a look at the second difference. When I go from 9 to 15, I'm going up by 6. From 15 to 21, I'm going up by 6. 21 through 27, I'm going up by 6. My second difference is the same. And I told you a couple of days ago, therefore, it is a quadratic function. Beautiful. So I know I have a quadratic function. Now we're going to take our calculator and we're going to input my two table of values. So I'm going to go under y equals, clear out everything that's there. And I'm going to go under stat edit and I'm going to clear out the y2s. And my y1s can stay the way it is. Okay, so now I'm going to enter in my second list. So I have 3, 12, 27, 48, and 75. Now, if you get a mismatch error, that means that your list 1 and list 2 have somebody that's not matching. Make sure you have, the same number in list 1 and in L1 and L2. Now what I'm going to do is I'm going to go under stat calc. And I know it's a quadratic, so I'm going to go under number 5, which says quad regression. And I'm going to hit enter. And this is what it is telling me. It is telling me y is equal to ax squared plus bx plus c. A is equal to 3, b is equal to 0, and c is equal to 0. So when I substitute that in, I get y is equal to 3x squared plus 0x plus 0, which is the same thing as y is equal to 3x squared. Now what I want to do is I want to check that in my calculator. I'm going to go under y equals. I'm going to type in 3x squared. I'm going to hit second table. And I'm going to verify that 1 through 5 agree, and they do. So therefore, I know I did it correct. Okay, let's go to page 52. Enrique is a biologist who has been monitoring the population of a rare fish in Lake Placid. He has tracked the population for 5 years and has come up with the following estimates. So now, I know there's 3 columns here. Here's the year, but I'm just dealing with the year since 2002. That's going to be my L1 column or my X values. And my estimated fish population is going to be my L2 or my Y values. So again, I'm going to eyeball my X values and I'm going to see that the change here has increased by 1. It is constant. And when I take a look at the fish population and I calculate this change, that went down by 101. From 899 to 796, I went down by 103. From 796 to 691, I went down by 105. And then the last one, I went down by 107. So right away I know it's not linear. My rate of change is different. When I take a look at the second difference, all of a sudden now I realize every single one is going down by 2. My second difference is the same. Therefore, I know I have a quadratic function. Okay, so now we're going to enter this back into our calculators. So you're going to clear out your lists. So go under Stat, Edit. Now, be very mindful. Here, believe it or not, I'm starting out with a 0 in my list. You have to make sure you have that in your calculator. So let's now clear out list number 2, and let's clear out list number 1. List number 1 goes from 0, 1, 2, 3, and 4. List number 2 is going to be 1,000, 899, 796, 691, and 584. You're going to do Stat, Calc, and I'm going to go down to number 5, which is quadratic regression. Hit Enter. Enter one more time. And I'm going to write out y is equal to ax squared plus bx plus c. A is equal to a negative 1. B is equal to a negative 100. And C is equal to 1,000. When I substitute that into this equation, I get y is equal to negative 1x squared minus 100 plus 1,000. I think that is my function. Now what you are going to do is go under y equals, and you're going to check it, clear out what's there. Negative x squared minus 100 plus 1,000. Enter. Second table. And again, make sure your table agrees, which I must have entered something wrong. Let's go under Stat, Edit, and I have okay, so I did make a mistake. I just found it. It should be minus 100x. I forgot that little x in there, folks. I'm sorry. So when I entered it into my calculator, minus x squared minus 100x. Sorry about that. Plus 1,000. This is why we check, to make sure that we're doing everything correct. Now you're going to hit second table, and my table does match up with everything that I'm showing in my graph. I have a 0, 1,000, 1, 899, etc. Okay. We have a couple of exercises that I'm going to go through. Number 1 with you on page 53, and then you have page 54 and 55 to do for me for homework using the calculator. So we have one more that we are going to go over on page 53. Okay, Bella is a BMX bike racer and wants to identify the relationship between her bike's weight and the height of jumps, a category she gets judged on when she races. She tests out 7 bicycles. So again, just count 1, 2, 3, 4, 5, 6, I guess we have 8 pieces of information here, and comes up with the following data. So I want to know what type of function am I working with here. So the first thing that I'm going to do is I'm going to look at my x values, and I'm going up by 1s. And that is going through that entire table. When I take a look at my height in feet, I realize that I'm going down by 0.08. And woohoo, I'm going down by 0.08 again. And that is going to be consistent through my table. So what type of function am I dealing with if I am going down by the same amount every single time? And right now you should be thinking linear. Y equals mx plus b. So you can take two ordered pairs. You can calculate your slope, which I want you to do right now. Then I do want you to put in one of the points, and I chose the 20 and the 8.9 as my x and my y to calculate your b. So I got my slope to be a negative 0.08x plus b. And when I substitute in 20 comma 8.9, I'm going to get 8.9 is equal to negative 0.08 times 20 plus b. And when I solve all of this, I'm just taking a shortcut, I get b to equal 10.5. So my equation is y is equal to negative 0.08x plus 10.5. It is a linear function, and that is the equation. If I am riding a 32-pound bike, so that is the weight, that is my x value. So x is equal to 32. You are going to substitute that in to your x of your equation, and you're going to find out the height that you can jump. So when you substitute in 32 for x and do all of those calculations, you are going to get your jump to be 7.94 feet. Now she asks the engineers to make the lightest bicycle possible. They tell her they could make a 10-pound bicycle. So again, that is your weight. So now x is equal to 10. And I want to know now how high she is going to jump with this 10-pound bicycle. So you're going to substitute in 10 for x, and you're going to get y to equal 9.7 feet when you do that calculation. What is the maximum weight of a bicycle if Bella's jumps have to be at least 2 feet high? So now I'm working with 2 feet high. 2 feet in height is my y value. So now if I substitute that into my equation, y is equal to negative 0.08x plus 10.5, and I substitute in 2 for y, I am now going to be solving for x. So right now, I want you to solve for x. Subtract 10.5 from both sides. You get negative 8.5 is equal to negative 0.08x. Divide both sides by a negative 0.08. And you're going to get x to equal 106.25. And what am I talking about? I'm talking about pounds. And that would be the answer for Bella. Okay, you folks now have page 54. I want you to figure out what type of function we have there, number 2. And you have page 55. And again, I want you to look at the cells and figure out what type of function you have there. Use your calculator to help you, and I will finish going over this on Monday. Have a really nice weekend. Safe.